Hi everybody. I'm sorry you're having to watch and listen to me. Our Chromebooks won't run this particular Phet simulation, so you're going to have to listen to me do it. We've been talking a lot about atoms, and now we're going to start moving to molecules and compounds and some very basic, simple chemistry. Chemistry is basically the study of how these things down here, which are atoms or elements, get hooked together to form different kinds of compounds. So at any rate, they've got a number of different simple molecules that we can make here. And one of the things we want to understand is the difference, it's a subtle one, between a molecule and a compound, and show you a couple other things that you see in science books all the time. So the first one it wants me to build is water. We all know this one, it's H2O. Well, the H stands for hydrogen. That little subscript in the formula tells that there's two of them in there, and the O stands for water. So I can build that molecule simply by going like this, and there is my H2O, and I can put it in there and it tells me I've successfully done that. One other thing I would just show you, just because we can't really ever see these things even with microscopes, and so one of the ways that books will show these all the time is with two different models. One's called a space filling model, which is what you're looking at right there, where they're kind of all pushed together. And probably the most common one is this one. It's the stick and ball model. You see this a lot because it helps show how the electrons are being shared. And as we discussed, electrons are what connect these things together. They're like the nubs in Legos. And chemistry is all about electrons because it's all about how we're sticking elements together to make different kinds of compounds and molecules. So I just wanted to show you that so you'd be familiar with that. This one here is O2. It's oxygen. So we'll go ahead and make our oxygen. That's just two oxygen atoms put together. And hydrogen, H2, hydrogen gas, is just two hydrogens put together. And then I got to get another one. Here's CO2. This is what we expel when we breathe. And so we have one carbon and two oxygens. So we have carbon, oxygen, and oxygen. And there we are. And then finally nitrogen gas. We put together like this, and we go down here. Now, I just made 5 molecules here. Every one of these is a molecule, but only 2 of them are compounds. All molecules, all compounds are molecules, but not all molecules are compounds. And the 2 compounds I have here are water right here, and our carbon dioxide. This is a molecule only, a molecule only, a molecule only. This is a molecule and a compound. This is a molecule and a compound. So one of the things we want you to do just from hearing that is, well, what's the difference then between a molecule and a compound? And that's for that. And you can see up here, these are called the chemical formulas, and that's how we write the names of molecules in chemistry. And you can see that they have the abbreviation, the same one that's used on the periodic table for the element, and then they have these subscripts down here to tell you how many there are. Here, the hydrogen, there's 2, and the O, whenever it doesn't have a subscript or a number, you just assume that it is 1. So you can see down here the carbon is only 1, so it does not have a subscript number next to it. Now these are all very, very simple molecules. Molecules get larger, and here's an example of a larger molecule of chloromethane. Now what we're going to want you to do for this is be able to write a formula for these, or from a formula be able to say, hey, these are the atoms that are in it, and here's how many atoms there are, or here are the different elements that are in it, and here are the atoms. Now when you're writing those things, we're not going to be too picky even about one part. Here is a couple of formulas for some pretty common things. Table sugar. The formula is C12H22O11. Sulfuric acid is H2SO4. What we would want you to do is be able to write these out, but more importantly than writing them out, be able to tell what kind of atoms are in it, or elements, as well as the number of them. So hopefully from reading this, you would be able to go, oh, there's carbon in there, there's hydrogen in there, and there's oxygen in there. There's 12 carbons, 22 hydrogens, and 11 oxygens. And so the total number of atoms in this would be 12 plus 22 plus 11. Same thing down here. We'd want you to recognize that there is hydrogen, sulfur, and oxygen in here, and there's 2 hydrogen, 1 sulfur, and 4 oxygen, so the total number of atoms would be those added up. Now, the rules, notice I put sort of for writing chemical formulas rather, because chemical formulas are a lot like rules in English. There's a lot of exceptions or a lot of little secondary rules that go in, but a good rule of thumb, if there's carbon involved at all, it always goes first. Carbon is an extremely important element to all living things because it's kind of the element glue that holds together living tissue. So because it's so important, we always put it first. Hydrogen also very similar, it always goes second, and then alphabetical order after that. And you can see with just the 2 formulas I wrote, I broke this third rule because right here we have an S before O, which is not alphabetical. But notice here, carbon first, hydrogen second, oxygen last. Here we have hydrogen first because there is no carbon. We have the S second because it doesn't have, it's only got 1. It doesn't have a subscript, and then the oxygen has 4. Again, we don't care if you can write these perfectly as long as whatever you write tells all the elements that are in, all the kinds of elements and the numbers of them. So, your first task in that is to go ahead and write a chemical formula for chloromethane, which is what you see right here. And I'm going to show you another molecule that I want you to do the same thing with in just a minute, so you may want to pause this while you write this chemical formula. Now, second on here, I want to show you another compound. This would be a compound and a molecule. I want to show you another compound that shows how much more complicated these can get, because I've just shown you very, very simple molecules and compounds so far. So here is a compound of caffeine, and you can see it has quite a few more atoms in it, and you can see the type of atoms there by the initials that are on there. And we'd also like you to go ahead and write the chemical name for this. And again, you may want to pause your computer while you do that. And lastly, I'm not going to ask you to make the chemical name for the next one. It would be cruel, but it's to make a point. And this is a molecule of insulin, or a compound, it's both. And insulin is made up of over 900 individual atoms, and they have to be arranged in exactly the right spot, just like you see here, in order for it to be insulin. I would never want you to try and do the chemical formula for this. One, you couldn't do it because you can't tell what all those atoms are, but also there's just too many of them. It would be very hard to do in this kind of a picture, but I did want to show you how complex molecules and compounds can become. And here is an example of a real complicated one. The other thing with insulin that is really impressive to me is if you're diabetic, you need insulin to help you survive. For years and years, the only way we could get insulin for people was to take it directly out of live pigs, I believe from their pancreases. And that's how we had to get insulin, which was very expensive and would also be subject to shortages. A generation or so ago, humans learned how to manufacture or make this compound, which is really, really amazing because it's so big. We can now produce this in laboratories, and we have a number of compounds, molecules that we can now make that don't appear anywhere that we know of anywhere in the universe. And a lot of them are in your clothing. One example of a totally man-made molecule is nylon, which a lot of you have in your clothing. It was used for parachutes in the Second World War and the like. That's right about when it was discovered. But you can't go anywhere and dig up nylon. Nylon is made by chemists taking atoms, breaking them down so they got the individual ones, and then putting them together to make all new materials that until man came around and started doing chemistry, we had never seen before. Another material like that is plastics. Plastics is a man-made molecule compound that we have learned to put together through chemical processes. And that's what chemists do. So, at any rate, hopefully after watching this, you have a pretty good idea of the difference between an atom and a molecule. You have an idea of the difference between molecules and compounds. You have a way, you know now how to interpret a chemical formula and say, hey, these are the atoms that are in it, these are the numbers of atoms, and you also have a little bit of appreciation for the ingenuity of modern chemists to make all sorts of brand new materials that have never been around in the history of the world, and as far as we know, the only place on the universe that those molecules and compounds exist is right here on Earth. And that's it. Thanks for watching.